Hello everyone, welcome to ODIA IITian. In this video lecture, we will discuss what is petrological microscope, its parts and mechanism with conoscopic and orthoscopic illumination. Now, what is petrological microscope? Polarizing microscope, also known as petrological microscope, one of the most important filter, that is lower polarizer, which convert unpolarized light into plane polarized light. There are four common types of settings for microscope observation. First one is plane polarized light, that is polarizer in. Second one, plane polarized light analyzer in. Third one, conoscopic polarized light and Bottan lens in. Conoscopic polarized light, Bottan lens and gypsum plates in accessory slot are in. Now this is the figure of petrological microscope. This is trinocular head, analyzer and upper polarizer, objectives, conoscope, internal light source polarized, that is reflected light source, accessory plate slot and polarizer. Now these are the parts. Rotating stage. This is the rotating stage. The thin section of mineral to be explained is placed on its stage. This axis of rotation of stage coincide with microscopic axis, that is crosshair. Polarizer, it is fitted below stage. Transmitted polarized light vibrate in east to west vibration direction. This is the polarizer. In this case, transmitted light passing through it, that is having east to west vibration direction. Similarly, analyzer is placed in microscopic tube above the stage. Analyzer transmits light vibrating north-south vibrating direction. Here in this case, analyzer is placed here above the microscopic stage, whose vibration direction is north-south. When both polarizer and analyzer are in position, that is known as cross-recall position. Eyepiece. The eye of microscope carries crosshair, that is north, south and east to west direction. Crosshair helps to locate a particular mineral grain for detailed examination. Here this is the eyepiece. Now, iris diaphragm. Iris diaphragm is located below the stage. It regulates the intensity of light that is coming to the rotating stage. Now, condenser. Condensing lens are located below the stage. They are used high power objective and produce a converging light ray. Similarly, another one, Bottan lens. Bottan lens is the important one. Bottan lens is used to observe interference figure. Moving towards mechanism of petrological microscope, which is the most complex part, but I will try my best to explain you in a easiest way. When vibration direction of polarizer, that is north-south, is parallel to vibration direction of plane polarized light, then it is become bright. If the vibration direction of polarizer is perpendicular to vibration direction of plane polarized light, then it become extended. Now, over a vibration direction that split in polarizer is perpendicular to vibration direction of polarizer, so that over a can't pass through the polarizer. यहाँ पे बोला गया है जब लाइट सोर्स से लाइट पोलराइजर को स्ट्राइक करेगा तब डबल रिफ्रैक्शन के थ्रू एक ई रे और ओ रे निकलेगा. यहाँ पे ओ रे का वाइब्रेशन डायरेक्शन इज perpendicular to lower polarizer vibration direction, that is north south and east west, so they cancel to each other. In this case O ray eliminate हो जाएगा, but lower polarizer का vibration direction is parallel to vibration direction of E ray, so only E ray can pass through the lower polarizer and hit the microscopic stage, that is anisotropic mineral is present here. Now, but E ray vibration direction is parallel to vibration direction of polarizer, so E ray can pass through it. Now, the vibration direction of E ray is changed after hitting an anisotropic mineral, that is vibration direction of E ray is east west become north south after hitting the mineral in thin section. यहाँ पे बोला गया है जब लोअर पोलराइजर को पास करके ई रे जाएगा, क्योंकि दोनों का वाइब्रेशन डायरेक्शन सेम है, ई रे का जो वाइब्रेशन डायरेक्शन है आफ्टर हिटिंग अनआइसोट्रोपिक मिनरल चेंज हो जाएगा. इन दिस केस ई रे का वाइब्रेशन डायरेक्शन था ईस्ट वेस्ट. आफ्टर हिटिंग अनआइसोट्रोपिक मिनरल it convert to north south, and due to double refraction E ray vibration direction converts to north south, and O ray also generate, which is vibration direction is east west. At lower polarizer O ray emitted but E ray passed through and reached the anisotropic mineral. At that place it split into E ray and O ray. Here vibration direction is changed after hitting and before hitting. In this case E ray पहले आया था lower polarizer से. After hitting anisotropic mineral it divided into E ray and O ray due to double refraction. E ray का vibration direction east west था, अभी हो गया north south, and O ray का vibration direction हो गया east west. Now the two ray, that is O ray and E ray, moves and hit the upper polarizer, that is called analyzer, which is perpendicular to lower polarizer. We already know that lower polarizer vibration direction is east west, and upper polarizer, that is analyzer, vibration direction is north south. So in this case where E ray and O ray that passing through anisotropic mineral hit the upper polarizer, which is called analyzer. Now O ray becomes O dash and E double dash. O ray becomes O dash and E dash, and E ray becomes O double dash and E double dash. Now after hitting E ray, it produced two ray, that is one is E dash and other is O dash, and another O ray produced, one is E dash, E double dash, and another is O double dash. In this case only E ray passed through the analyzer due to having parallel vibration direction with upper polarizer. In this case O dash and O double dash का vibration direction is perpendicular to vibration direction of analyzer, so they are eliminated, and vibration direction of O ray is E ray. The vibration direction of E ray becomes parallel to vibration direction of analyzer, so only both E ray can pass through the analyzer and we can see in the eyepiece. Now both O rays emitted only E ray pass through it and see it at eyepiece. In this case light 3 times doubly refracted. Now this is the first time where light doubly refracted. This is the second time in the anisotropic mineral, that is the second time doubly refracted. This is the analyzer, which is the third time that light doubly refracted. At that place two E ray may shows constructive interference or destructive interference. यहाँ से जो फाइनली दो E ray निकल के जा रहे हैं, इन दोनों का wavelength are different, so they produce constructive interference or destructive interference. Now conoscopic and orthoscopic filter are placed in between lower polarizer and microscopic stage. ये आपको याद रखना है. और conoscopic and orthoscopic filter को कहाँ पे प्लेस किया जाता है, that is the in between lower polarizer and microscopic stage. If E ray shows constructive interference, then the intensity of light increase, so a higher visibility of color is produced. In this case the two ray that is passed through eyepiece, if they produce constructive interference, then that's so higher visibility. If they produce destructive interference, then the intensity light decrease, so that lower visibility of color takes place in the image. Now these are the important part. The property we can analyze in plane polarized light are color, heliochroism, relief, refractive index, twinkling, cleavage. Similarly, the properties we can identify through cross nickel position. In this case both analyzer and polarizer are used, that is the isotropic and anisotropic property of mineral. extinction, interference color, interference figure, and optically sign positive or negative, and twinkling. Now this is the one of the most important part, that's the examination of isotropic mineral in cross polar. In this case, isotropic minerals does not show double diffraction. If a thin section of an isotropic mineral is viewed in cross polar, it appears dark. Reason is due to light coming from polarizer pass through the isotropic mineral which is unchanged. In this case, there is an anisotropic mineral, so it is showing double refraction. But in this case, in the case of isotropic mineral, they never show double refraction, so that is unchanged. An analyzer caught the light completely, the result at place. In this case, the light is coming from polarizer that not doubly reflected, so that their vibration direction not change. And we know the vibration direction of polarizer and analyzer are perpendicular to each other, so they become cancelled to each other, and we see the darkness, which is the extinction. If the position of mineral grain is changed by rotating the stage, it will remain dark throughout the rotation. Now we are going to discuss important difference between orthoscopic and conoscopic illumination. In orthoscopic illumination, mineral illuminated by bundle of parallel rays. In conoscopic illumination, mineral illuminated by cones of rays. You can see in the figure that light is hitting with parallel rays, in this case in a conoscopic manner due to the presence of condenser lens. All rays travel along same crystallographic direction. In this case, all rays travel along different crystallographic direction. This is the most important point. In this case, polarizer and analyzer is used. In this case, polarizer, analyzer, Botton lens are used. No accessory plate is used. Only high power objective is used. Both high and low power objective is used. This is used for study of interference figure. In this figure, we can notice here that there is a Botton lens present here. Botton lens is present above the microscopic stage and below the analyzer. Similarly, this is the condenser is present here, which converts the light into a point. Now, this is one of the most important formula. In this case, यहाँ से कभी आज तो क्वेश्चन नहीं आया है, पर बहुत जल्दी गेट एग्जाम में आ सकता है. You can see here, this is a full wave from 0 degree to 360 degree. This is the, in this case, phase is 90 degree, phase is 180, 270, 360 respectively. Now, you can see here, these are the points, that is one division on x-axis, that is 1 centimeter. Now, at any point, we can find phase by this formula. This is the important formula. जहाँ से अगर हमको फेज पूछा गया है तो हमको पॉइंट x डिवाइडेड बाय लैम्बडा which is the wavelength into 2 pi is the formula, where x is the position of point where phase or path difference हमको पूछा गया होगा, and lambda is the wavelength. Let a point P, let P is a point, we have to find the phase. इस P point में हमको phase पूछा गया है. In this case we know phase में x का value equal to 10 divided by lambda which is wavelength is divided by 10. We know pi equal to 180 into 2, that is the phase is 360 degree at point P. Similarly another point, that is Q. यहाँ पे x का value is 2.5 and lambda is 10. So 2.5 divided by 10 into 360, that is 90 degree. हमको अगर इन दोनों के बीच में फेज डिफरेंस पूछा गया, P पॉइंट एंड Q पॉइंट का फेज डिफरेंस बताओ, तो इन दिस केस 360 डिग्री minus 90 degree equal to 270 degree. It is one of the important formula जो कभी भी इन फ्यूचर क्वेश्चन में आ सकता है. You have to remember this. If you want the notes, then join our Telegram group ODIA IITian. Link is given below. Thank you for watching this video lecture. If this lecture is informative to you, please like, share and subscribe. Thank you.